ഗസ്റ്റ് സ്പീക്കറിലുണ്ട്. നമ്മൾ ഇംഗ്ലീഷിലാണ് സെഷൻ ചെയ്യുന്നത്. സോ വെൽക്കം ടു അനദർ സെഷൻ ഓഫ് ഡെവോപ്സ് മലയാളം. ഇന്ന് വുമൻ സ്പീക്കർ മന്തിന്റെ ലാസ്റ്റ് സെഷൻ ആണ് ഈ മന്തിലത്തെ. എല്ലാവർക്കും അറിയായിരിക്കും ഈ വർഷത്തെ വുമൻസ് ഡേയുടെ തീം എന്ന് പറയുന്നത് ഇൻസ്പയർ ഇൻക്ലൂഷൻ ആണ്. സോ ഇൻസ്പയർഡ് ബൈ ദാറ്റ്, I'm sorry, I suddenly started talking in Malayalam, which I should not be. Yeah. So most of you might be knowing that this year's theme for Women's Day is a woman inspire inclusion. So inspired by that, we are also doing a Woman Speaker Month, which creates a platform for which is inclusive for everyone. So we means DevOps Malayalam community. So a bit about the community. So we are a community of DevOps, SRE, and DevSecOps practitioners and aspirants, which was started back in 2021. So the community was first started in Clubhouse, and now we are active in LinkedIn, YouTube, WhatsApp, Telegram, through many channels. And we usually conduct online guidance sessions and workshops via Google Meet, and few offline sessions like DM meetups conducted in Trivandrum and Cochin. So Women Speaker Month was actually introduced in 2023, which was last year. So this is the 2.0 version, second version in this 2024. So the first 3 sessions before this was based on Kubernetes offerings of the major cloud providers. And today's speaker is Divya Mohan. She is talking about WASM, which is WebAssembly. Small introduction about her. She will say the remaining things. She is an open source leader, a community, extensive community contributor at open source, and a maintainer at Kubernetes. I'm sorry, I'm getting disconnected. Okay. About the session flow, remaining things Divya will talk about her. And about the session flow, the talk will be of approximately 45 minutes. Correct me if I'm wrong, Divya. And there will be a dedicated question answer session at the end. You can ask in English or Malayalam. We can manage that. And ask questions in the chat specifically. We should not be interrupting Divya in between. We'll take all the questions at the end. And we'll provide feedback forms also. You should definitely provide feedback about the sessions. And there will be key takeaways and video shared in our YouTube channel later. So I'll give the floor to Divya. It's all yours, and we are yours.
Thank you so much for that wonderful introduction. Also, I do not have a problem with Malayalam. I'm just speaking in English for the sake of the other participants here. I'm also Malayali. I'm just not getting into that zone right now. But I will share my screen and start the presentation right away without rambling. Do we have to record by this by any chance, or are we already recording?
So we will start the recording. Yeah, so Ibn is recording.
Okay. If it's starting recording, let me know. The thing is, I did not get a pop-up saying that recording is in progress, which is why I paused before starting out.
Ibn, do you find any difficulties in recording the session, or should I? Oh, it's with an external software, so it's getting recorded. Yeah, so no worries, you can go
Okay.
ahead.
Oh, okay, great. So, hello everyone. I am Divya Mohan, as Hema correctly introduced me. Thanks for that wonderful introduction, by the way. Today we're going to be not going to go very deep into WebAssembly, and I'm just going to give everyone here a 10,000 feet overview of what WebAssembly is, and hopefully provide you with a little more context around where we are currently as an ecosystem and where we are headed. All right. So as Hema correctly introduced me, I am not going to go into the job role specifics, but I am a Kubernetes maintainer. But specific to this talk or webinar or session or whatever you want to call it, I think one of the things that I'm most interested in highlighting is that I'm also a recognized contributor to Bytecode Alliance. Now, Bytecode Alliance is one of those organizations that's actually responsible for developing and maintaining standards around WebAssembly alongside W3C, CNCF, and a couple of other organizations. So I'm a recognized contributor there, and we are also starting up a community special interest group within Bytecode Alliance, which we are in the process of forming. So once we know more about how we want to structure our meetings and everything like that, we'll definitely let you know. So I normally start off presentations talking about why I chose the topic and why I want to explain more about this topic. But essentially, I know that a lot of you might have heard about it, but do not know exactly what is WebAssembly. And even for those of you who've not heard about WebAssembly, the term itself sounds very weird, right? Web is, the front end, and assembly is like machine level language. So, what exactly is WebAssembly? If you look at the WebAssembly specification, which I will get to defining in a bit, it's essentially something that was announced in 2015. It is a bytecode format, and the version 1 of this specification was announced in 2017. I've underlined it here because it's also the version of WebAssembly that's being leveraged across the ecosystem, whether it's in the browser, whether it's in the cloud native ecosystem. That's the version that's still being used, even though the version 2 draft was announced 2 years back. There's also other couple of milestones when you talk about WebAssembly, which is the WASI standard, which we shall come to in a couple of slides. But essentially, WASI is a supplementary standard to the specification of WebAssembly. Now, what does the specification of WebAssembly actually define? So, WebAssembly is essentially the output of a compilation target. It is um, it is defined to be a bytecode format which is portable across architectures and languages. And the fundamental unit of WebAssembly, that is the specification, just like we have program within programs, we have functions, we have structs, we have a lot of other higher level constructs, and we have lower level types like ints, floats, and everything else. The fundamental unit within a WebAssembly program is that of a module. Now this module is supposed to be sandboxed, and by sandboxed, I mean that it basically does not have all the frills and fancies that you would associate with a higher level programming language. Now, what frills and fancies am I talking about? When you write a program, you want it to interact with the operating system, right? You want it to interact with the memory, you want it to deliver an output, give it some inputs, stuff like that. That is what a program does. It's basically a reactive piece of software. But WebAssembly's module is sandbox and basically does not have any of these capabilities inherently, which is also a great thing in addition to being a disadvantage, because if you are not able to actually interact with it, you obviously cannot write a lot of programs very well, because what would you do if the program is not able to reach out to the network? What if I'm giving it an input and the format doesn't basically listen to me? What is the whole use of writing the program, right? It should respond to my input, it should give me an output. But essentially for that we have standards like WASI supplementing it, and that was why it was created. And you might think that all of this is basically for the web, because the name itself has web in it, right? So you might think, hey, this is for the web, and essentially it is sort of a you know thing to make web applications better. But it's not, because it's a misnomer. It's extended now to the cloud native and other ecosystems, like AI, like serverless. So there are ecosystems other than the browser one that are currently using it, and it's not limited to the web alone now, although it was initially conceptualized with the web in mind, because web applications are the easiest to target when it comes to um, you know hacking. It's, let's put it that way, like if you actually want to um, maneuver your way into a web application, it's easier than most. So that's why we're like, not just with the focus on security, but also with the fact that JavaScript, HTML, CSS, all of those languages that are typically associated with the web weren't exactly delivering the performance that was expected of them when it came to more complex applications. There were efforts underway from a really long time to find out alternatives to complement these three languages of the web. So, WebAssembly was conceptualized initially for the web, but it's now moved way, way beyond the web. And one of the common things when I started out, that I made a mistake with, is capitalizing WASM, which is WASM. Now, unfortunately, that's not the way it's written. It's capital W and small case ASM. It's just how it works. And if you um, write it as WASM capital, you might not be referring to the same thing. So as I was saying this, a lot of y'all might have thought, I know as a sysadmin, when I heard about this, right, I used to work extensively with Java and JVM and JavaScript, because a lot of the applications that I worked with in my previous jobs were web apps and mobile apps related to banking and the financial organizations. So, a lot of y'all who are sysadmins, or even if you're front end developers, you would have thought that it sounds very similar to the JVM bytecode, right? And if you're from the front end side of things, you'd say, hey, that's pretty much what JavaScript does too. Like, it brings more languages to the front end. And with Java, you have an entire ecosystem of Jython, JRuby, Clojure, Groovy that actually um, got introduced into the Java ecosystem, in terms of dynamic programming languages. So, WebAssembly also seems like a similar effort. And that is with intention that I have sequenced the slides that way, because JavaScript and Java in general were not designed to be compilation targets. Now, when I say compilation targets, I mean that they were not supposed to be the de facto language that all other languages compile to. When you bring languages to a particular ecosystem, they have to compile to a base language and then further go down to the machine level language, right? So Java and JavaScript were not designed to be that. They were designed to be programming languages, and they were designed to basically function as programming languages. They got famous later on because of the community around them, and more people actually rallied around bringing more languages, dynamic languages to the ecosystem is another matter altogether. But they were designed to do one function, which they did pretty well. But when you actually ask something to do a particular function which it's not designed for, there's obviously going to be a lot of there's going to be a lot of friction. Firstly, because you have to hack your way into things. You have to make it behave a particular way. So in the example of Java, what happened is Java was not designed to be a compilation target. All these dynamic programming languages that I spoke about that were brought into the Java ecosystem were an afterthought. In fact, one of the papers that I linked to at the end clearly states that the opcode in invoke dynamic was added as an afterthought to support the dynamic languages that were targeting the Java runtime. It was not, designed initially with the concept of it being a compilation target. So there were issues that came up. Similarly with JavaScript, if you worked with JavaScript, if you written a front end app and watched as it grew more complex, you would definitely know that JavaScript in general suffers from a lot of performance issues when we actually increase in level of complexity. Take any AIML app, take all your online multiplayer games, take Adobe Photoshop or Figma that you use online. When you try to execute them on a web browser, see the amount of lag that they actually get. Now they've actually improved because they also have switched over to WebAssembly. There are a lot of gaming companies and Adobe themselves have that actually use WebAssembly as a base. um, but I have been speaking about compilation targets and how WebAssembly is a compilation target, right? How it is designed to be one. Why are we talking about this? Now, as I mentioned before, there's been a lot of focus on security in the cyber app space because um, people are increasingly worried about how their data is being used, how their privacy is not taken into consideration, even with things such as cookies on the web browser. And it's essential that we try and provide as um, much of safety as possible when designing software. So just recently, this is from last month, uh, there was a press release that actually was put together after the US government actually collaborated with various leaders across the industry, and there was a call to address um, the root cause of many of the worst cyber attacks that you've ever seen in recent times. A lot of it actually does boil down to the use of programming languages that are not memory safe. Now, it's not the only reason. I get that, like memory unsafe programming is not one of the only reasons. We have other stuff as well, but the more that we can mitigate one form of attack, the better, right? And essentially, WebAssembly allows you to do this because of the inherent way it's designed. I talked about WebAssembly's module being sandboxed and secure. Um, and I know that a lot of it sounds like very high level, but essentially, when you talk about that module being so sandboxed that it cannot access the operating system that it runs on, and is only able to perform what it has been asked to, you have to actually implicitly state that this has to be done via imports and exports. Then your memory safe programming comes into the picture. This is very, very safe, but it's not to say that this is the only way. There are other memory safe programming languages like Go and Rust that are being developed, and have a vibrant ecosystem around them. But WebAssembly as a layer on top of all of this can really help with the kind of sophistication that we're dealing with when it comes to cyber attacks. And when I spoke about the history of WebAssembly, right, I also said that there was a standard that was developed, because WebAssembly on its own cannot actually access all the things that it needs to. Uh, as a program, right? You need to run something, you need to have outputs, you need to have inputs, you need for it to have that glue to the host and glue to the operating system to actually work. So WASI as a standard was announced in 2019, because we recognized that this was a requirement. And as we move towards the server side, there was a lot of discussion and debate, right, on how we should go about doing the development around WASI. Some believed one way was particularly better than the other. There was a fork in the community around how to do this. We will also get into it towards the end. But essentially, as of today, WASI Preview 2 is the one that's being standardized and developed along with W3C, CNCF, and a bunch of other organizations. And that's what we will be looking at in the course of this presentation. Also, it was announced just in January, the version 2 of WASI, January 2024. But along with that, if you've been clued into this space, there's also a lot of stuff that's floating around. Like WebAssembly has found applications in a lot of other ecosystems. But even with the WASI standard, right, there's a lot of things that a lot of people don't understand. I myself did not understand a lot of things when I started out. Like, what is the component model that WASI is actually being developed under? Why do we need the component model? Why do we need WASI? What is this whole ecosystem um, actually end targeting? What is our end goal? All of this will make sense, I promise, at the end of the presentation, or at least I'll try to make sense of it, and hopefully we can have a good discussion later on. But when I talk about WebAssembly, the definition itself, I said that it was a bytecode format, right? And how does that work? Because as a sysadmin myself, I'm like, this doesn't really make sense. Like, we deploy applications somehow magically end up displaying on the screen. We have a runtime underneath where we deploy them, and that basically magically displays on your browser or on your mobile, or it's an app on your mobile for some of it. How does this actually work when we talk about WebAssembly? Now, for that, we need to go back to basically how programming works. So, when you write any piece of software, it's going to be in some language, right? A higher level programming language like Rust, Go, Python, C++, Java. And essentially, when you're writing that, you're not going to write it in zeros and ones, which is the language your computer understands. You are going to write it in a language that's familiar to you, that's closer to English, maybe. So essentially, what you talk and what your computer understands are not the same thing. So you need a translator in between. And that is what the compiler does. The compiler actually takes your code, converts it into an intermediate representation, and that intermediate representation is then tailored to the architecture that you're running on. There are more architectures, of course. I have just taken the main two. But unfortunately, due to the number of languages that we have and the number of libraries and ecosystems that have developed around these languages, the intermediate representation across languages and their libraries are not standard. So, what happens is, when we talk about intermediate representation, there are three different categories that it can fit into. There's low level intermediate representation, which is as close to machine code as it can get. And then there's high level intermediate representation, which is closer to the programming language that we sort of write or code in. And the mid-level IR basically combines elements from the other two. uh, and when we're talking about intermediate representation and trying to standardize this intermediate representation, all of this all of these efforts aren't new. If you've been in tune with the ecosystem, you would know that there have been predecessors to the WebAssembly effort that's ongoing since 2015. So before WebAssembly, there was ASM.js, which was a specification started by Mozilla, and funnily or not so funnily, there was also the native client and portable native client that was being started by Google and was being developed by Google at the very same time, right? This was early 2000s probably, um, and into late 2000s, closer to where we are right now. But even before that, like we saw in the first couple of slides, we had JavaScript, we have um, the Java bytecode and the JVM. And if we go further behind, like into the 1970s and 1980s, I'm sure none of us were born then, but we had like Pascal speak code and IBM Timmy at that point. So trying to get that intermediate representation right and standardized across the ecosystem has been an endeavor we've been taking on since quite some time. And that is where WASM comes into the picture, because essentially what the fundamental unit is basically a module. And what you do is you don't have to write the WASM module, you have to write your code. You have to write your code in the language that you typically know and are familiar with, like maybe Python, for example, because that's the thing that I was most familiar with as a sysadmin. So Python, and you take it into a compiler, and if Python's compiler supports WebAssembly, it will output the IR in the form of a WASM module. And essentially, that module can be taken and run anywhere, right? That WASM module not only is able to run on different CPU architectures, but it's also able to run within a browser, which is also a supported runtime. It's also able to run inside a container, which with a supported runtime. It's able to run at run on edge devices, which have CPU architectures that are very different from the ARM and x86 architectures that we know. So essentially, what the WASM module needs is just a runtime that supports it. Installing that runtime and developing that runtime is what we as an ecosystem need to support and further. But for those of you who have been familiar with Kubernetes and containers and container orchestration in general, would ask, hasn't this actually been achieved with containerization? Uh, Not really, because what a container does is, if I can explain it in the simplest of terms, you take um, an application and its environment and suppress it into an image. Now, how it's done is the base layer is going to be that of an operating system. Your layer 2 will be whatever runtimes. Maybe you want an nginx server or an apache server, and then you have the layer 1, which is basically your application. You actually take all of this, you pack it into a container image, and that container image is what runs on your container runtime. Now you would say, okay, so WebAssembly requires a WebAssembly runtime and container requires a container runtime. So what's the difference? Now the difference here is that the container runtime actually needs to run on a host. It cannot You cannot have container runtimes running in browsers. I have never seen Docker run in a browser, like a Docker runtime. and you cannot essentially do that because of the constraints that containers have. And essentially, WebAssembly is able to do that, because what WebAssembly does is not pack your entire application and its surrounding environment and dependencies. It's just taking your code, compiling it into a module that's more understandable by a supported runtime, and that runtime can run on a host. Now that host can be different. It can be a browser, because the browser itself is a host that runs on top, runs on your laptop or runs on your physical machines. But that wasm runtime, which may not be a browser, can also be just a runtime like WASM time or WASM edge, which is running on on just a device like an edge device, for example. So the WASM module just needs a runtime to function, but a WASM, but container or a container orchestration tool actually needs an entire set of things other than the WASM runtime. So WASM module um, actually can run pretty much anywhere, whether you're talking about browsers, whether you're talking about CPUs, whether you're talking about operating systems, whether you're talking about even containers themselves, because WASM modules today can run on containers, inside containers, by spinning up their own runtime. Now, when I'm talking about WASM modules running anywhere outside of the browser, we need it to communicate to the external host. Because if you do not communicate with the external host, none of what I said actually matters. Because you can write very beautiful code, have a compiler compile it to WebAssembly, but it's actually not going to work if it's not able to communicate with your laptop or your machine. So WASI as a standard was required to be developed, and this is how it began actually. WebAssembly modules were sort of designed to actually work within the browser only as the runtime. So a browser runtime is a little easier to conceptualize than the other runtimes that we actually work with, because WASM modules were designed for that. But then we realized the benefits, right? We realized that sandboxing can actually reap benefits if we take it to the server side ecosystem as well. So we actually brought up a set of APIs and started developing them and standardizing them, so that WebAssembly as an ecosystem could be taken outside of the browser. And these standardization efforts were led by the WASI subgroup, which is one of the subgroups under the WebAssembly community group in the W3C. So W3C is the one that develops the standards for the web. So the WASI interface, sorry, WASI standard is being developed as a set of APIs. So how WebAssembly is essentially going to contact the host is through APIs. Now, I'm assuming that we all know what APIs are, but in case we don't, APIs are just like those um, bridges that we open up between one app and another. Simplest way I can explain is that if all of us have pretty much used Uber or Zomato or some form of food delivery or ride sharing app, right? If Uber or Zomato or any one of them were to develop maps on their own, uh, it would mean a lot more effort for them, because when we track all of that information to get real time traffic, to get real time access to the location, to get all of that is a lot of effort put in by one company alone. So what they do is they call on the API for Google Maps. They open a bridge to the Google Maps so that they can take the location from there. They can actually, do a whole transmission of data from there, and show you real time location, show you real time uh, sort of data on how fast it can get to you based on the movement from that location. So this is just a small example of what APIs are, but this is what we're trying to do with WebAssembly as well. Your module is going to be a sandboxed one. Essentially, when the program demands that we need access to the network, or we need access to take inputs or deliver outputs, or we need access to XYZ part of the um, you know XYZ part of the file system, the APIs are going to sort of open up to get that sort of information and allow it to do that particular function. So our aim with WASI, and somewhat of what we've achieved right now, is that essentially a WASM module is running on all these places right now. Whether you're talking about containers, whether you're talking about browsers, every browser, by the way, whether it's Google Chrome, whether it's Safari, whether it's Mozilla, um, whether it's Chromium, any of them, all of them actually have support for WebAssembly right now as we speak, the latest versions. So essentially, a WASM module is able to run anywhere and not just the browser, was our aim with WASM. Now, when we talk about system interface, right? Because the full form of WASI is WebAssembly System Interface. It's kind of like what I explained to you. I explained it as a bridge, but I think um, you know this blog that I've linked here actually explains it way better. It talks about the system interface being a door. So when you go to a person's house, you essentially knock on the door or ring the bell, so that you can sort of go and meet the person, or whatever work you have with the person actually gets done, right? Essentially, a system interface is just like that. Applications need to access certain things in memory. Maybe it's the file system, or it's a specific set of data that's stored there. But it has to go through system calls. It cannot directly access it, because imagine if everybody and anybody were able to access your house. Thieves would just run in and wreak havoc, right? So that barrier, or that layer of protection, is known as a system interface. And how WASI actually proposes to implement it is through these various pipes. But the core is going to be developed as the one that deals with the basic functions, such as access to files, access to networking capabilities, access to IO, access to streams. And then we branch out into processes, graphics, multimedia, because all of those are good to have. But essentially, you start out with the basics when you're developing even programming language, right? Even if you're thinking of developing a programming language, what would you want it to do first? You would want it to actually be developed in such a way that whatever I write in it makes sense to actually program and actually execute. Without it executing, there's no sense if I'm just writing it for the sake of it. So this is how BASI as a standard proposes to implement it. Now, I mentioned several slides back that there were that WASI actually was introduced in 2019, and it was announced as a standard back then. But when we started developing it, what actually ended up happening is that we didn't stay true to our um, goal. The goal was to actually develop a core, and around that build those various functionalities, right? So we started building out that core, and it was the APIs that were developed actually were heavily reliant on Unix like um, you know standard interfaces and Unix like command shells. So it was also uh, very reliant on Unix like operating systems. And essentially, given that Unix and Unix like systems are the majority, it was fine. But then when we are talking about portability across languages and across architectures, Unix is not going to be the only one operating system, right? You have to have you have to have support across operating systems, across languages, across architectures. So that's where we sort of didn't adhere to it, even though as a starting point it was a great place. So the challenges were mainly that it didn't make sense for for some other platforms, because the Unix like focus actually made it low on portability. In the case of Windows, it ended up requiring a Cygwin like layer, and for web for the web, right, when we were developing this to give it additional capabilities, it just didn't make sense. And when we were developing the first version, the actual core that was being developed ended up being way too monolithic. Now imagine if you want to take an implementation and actually make it portable. It should be able to plug and play into things. You should not have like a huge block that you can only plug into another huge block. That doesn't work. You have to have things that are movable, that are plug and play. And having that monolithic ABI implementation didn't work, in keeping in view our larger goals. That is how we switched to WASI Preview 2. And before I move into WASI Preview 2, we have what was supported in case of WASI Preview 1 on the slide. We have system clocks, we have all the basic stuff that was supported. But as I said, this is not the direction the ecosystem wanted to head in. Some people actually decided, okay, this is what we want. We want the simplicity, we want justice. So they decided to have a fork, and that is known as WASI X right now. And WASI X actually is is basically continuing what WASI Preview 1 brought into picture. But WASI Preview 2 adheres to the larger goal and is being standardized right now. So it is basically a more plug and play, so more modular, and you can actually take what you want and leave what you don't. And what we're trying to do with WASI Preview 2 is provide a stable definition of commonly used interfaces for library developers. In the other case, we were providing a stable definition, but it turned out to be way more monolithic because we were trying to put all of it in one big block. And when that happens, it's very difficult to adhere to the larger goal of making it more modular. So WASI Preview 2 is more modular at this point. And how is it doing that is by defining worlds. So essentially, when you talk about modules, and if you're talking about plug and play, we saw earlier on, right, the intermediate representation of one language is not very similar to the intermediate representation of another language. So when you define, say, imports and exports in Go, and you actually want that same component, or when you want that same program to be incorporated into Rust, what would you do? You would actually rewrite the program in Rust, and that's what a lot of people do even today. um, if you want the functionality in one language to be replicated into another language, you just rewrite it, because that's the smartest thing to do at this point. But with WASI, what we're trying to do is we're trying to say that, hey, if you've written a particular functionality in one program and you've actually compiled it to WebAssembly, you just need to import it into another program. Literally plug and play. And that's how it should work. So basically, that world will be um, describing the import and export of that particular component, and that will actually seamlessly plug and play into the program that you're importing it into. It can be used to represent the execution environment of the component. And given the current status of WASI 0.2, there are two worlds that are introduced. One is the CLI world, which provides a CLI like environment, and an HTTP proxy world, which is basically to stream in and out your HTTP requests. These are the APIs launched as part of WASI 0.2, and you can see that there are a lot more APIs that have been added. And I spoke about components a little back, and I said component model, right? So what is a component? And to understand that, again, we go back to the WASM module. When I said earlier, right, like everything doesn't compile to the same, um, IR. It still holds true with WASM modules as well, because the intermediate representation does not really change, irrespective of whatever you talk of, whether you're talking about WebAssembly, whether you're talking about other things. So what exactly happens is WebAssembly, at its core, defines things in ints and floats. Those are the only basic types available. If you've worked with programming languages, you know that that's the first thing you learn, types of things you can define, um, your variables and your constants by. So WebAssembly module has only things for ints and structs, and everything that you see on your screen right now will be in the form of ints and structs. Sorry, not ints and structs, ints and floats. And this is how it exactly looks like. If you see here, you won't see a lot of things that make sense to you, because that's how low level it is. And essentially it's the output of a compiler, so it should definitely not make sense unless you are a compiler or you know how to read with. So richer types, like we deal with richer types such as strings, right? We want to pass strings, we want to say hello world, that's our first program. We want to write hello world and we want it to be displayed on the browser. And for that also we have to use ints and floats. And when we talk about WebAssembly's intermediate representation across languages, these ints and floats are represented differently across different languages. So if I'm trying to zoom into this one, basically if I am saying that, hey, you know what, this is a string saying hello world, and I'm trying to implement it, I'm trying to import that small program into Rust, as part of a larger program. The Rust compiler is going to say, hey, that doesn't really look like a string to me, because at our core we are different. And that's where those pipes come in, right? That those various plug and play things which are called as import and export. So what it does is, obviously your intermediate representations are going to be different. So I am going to define a layer that actually um, defines imports and exports at a very high level, and it's standard across languages, across libraries. So your richer types are defined in the same way. So essentially when you're trying to achieve, just a second, when you're trying to achieve this, this cross won't be anymore there. um, when you define that component, you actually have the plug and play stuff already in, and you can actually just import into and export out of seamlessly, because you have those things defined by WebAssembly itself. You're not going to rely on your compiler or your language specific representation to do it, because if you rely on language specific representation, it's going to look different for everything. So what we're doing is, the language specific representation, of course, it will be there. The core WASM module will still have all the things that it had, but around it we have a wrapper that sort of that sort of defines the imports and exports in a way that you can actually seamlessly import and export stuff from one program into another. But all of this doesn't really make sense still. How is this relevant to cloud native, and how is it relevant to what you're doing, right? So bringing this whole diagram back, when we talk about um, WASM modules, fundamental unit is the WASM module, right? And when we talk about where it can run, it's the WASM runtime. Just like how you need applications to run on particular middleware, or you need a container runtime for containers, you have WASM modules with WASM runtime. And when we talk about WASM runtimes, they can run in all the hosts that you can think of, whether it's the edge, whether it's the uh, different types of operating systems, whether it's a container, whether it's a browser. And one of those areas is Kubernetes. And that's where we're going to go next. And hopefully, I'm able to demo this well. So I am actually, hopefully, let me see. Just a second. I'm going to do this quick demo. Rancher desktop should be visible on your screen right now. Please, can someone confirm if that's the case?
Yes, you
All
can
right.
see.
Okay, so Rancher Desktop is, of course, it's with the company that I work with, but it's one of the newest features that we've released with respect to WebAssembly. Right now, what I'm trying to do with this demo is that I'm going to run a WebAssembly application inside the K3s cluster that's already inbuilt with Rancher Desktop, and it comes packaged. So you don't have to actually download a separate thing. You can just download the image of Rancher Desktop relevant to your um, operating system, install it, and it will automatically install all the other things that it comes packaged with. So we have K3s and Helm that's packaged within this already. So you have one K3s cluster. So if you want to see that, I can just show that to you right now. Hopefully this works. If it doesn't, okay. So there's a service running here already. And if you want to see the namespaces, that's also, see, these are all these namespaces that are there. Now what I'm gonna do is, sorry, that was not my intention. um okay, this is not behaving properly. Okay, so my intention is to actually um, run a WebAssembly workload inside the Kubernetes cluster. Now, Rancher Desktop does allow you to do that with in two separate ways. Now, the first way is you run a WebAssembly workload just as you would run an application inside your pods, right? So you have application pods. In the same way, you can run WebAssembly workloads inside your pod, and then you have WebAssembly workloads that run directly on your K3s cluster, just like your pods, right? And these are two separate ways that Rancher Desktop offers the way to run WebAssembly workloads. What I'm going to do, for the sake of simplicity, is to just run a WebAssembly workload inside a pod. So as you can already see that there's this cluster we have running in the latest release. I'm gonna click the preferences here, and hopefully it opens. Today it's not doing its job well. Yeah, okay, it opened up. Now if you can see here, we have experimental support for WebAssembly enabled. Now what this does is basically it enables the spin framework to run on Rancher Desktop. With this, what we can do is we can run it directly. We can run WebAssembly workloads directly on Rancher Desktop. If we have the Mobi runtime enabled, which is the Docker runtime, but if we do not have the Docker runtime enabled, right, we can still use runtime classes and run the WebAssembly workloads inside a pod like we do with a normal container. So I'm just going to click enable here and clicking apply. So hopefully it should restart in a bit. Let me see if this is actually working. I'm just going to apply the update as well. But essentially, this is going to take a while. But I can take questions for a bit right now if anybody has anything, because we're going to wait for the updates to apply so that we can actually start up. So, does anybody have any questions?
Yes, we have few questions in the chat.
Okay.
So we'll address that. Adib, we'll come to you. I see your hands are raised. Uh, yeah, first question was from Adib itself. What do you mean by web application here? Is it front end or back end? I think it was like one of the first questions we received.
Okay.
Uh,
So
It's
web
one of the first.
applications are basically applications that you run on the web. So it obviously does include a lot of front end development, but those web applications actually do have to connect to some data source, right, at the back end. So that does involve a fair amount of back end development as well. So I would say that it's a combination of both front end and back end, because without whatever you display on your browser is just the front end development that you're doing, but that has to actually connect to something behind, like whatever you enter in as your credentials, whatever you enter in as your data, right, it gets fed to a database or some messaging queue at some point. So there is a fair amount of both front end and back end data, back end development that's involved. Does that answer your question?
Apologies, my question was little different actually.
Okay.
So initially, I didn't understand the main concept. Like this is a framework which is applicable for both front end and back end on a separate context, right? So I didn't understand that. So that's why I asked that
Yes.
question. Now, after a
Okay,
couple of
okay,
slides, I
no
understood
problem.
that. Yeah, thanks.
Yeah, yeah,
Do you
no
have any
problem,
more
no problem.
question,
It is
Adib?
confusing to
Hello.
understand.
I have little
Yeah, hello.
couple of questions there, which is related to production grade applications. If other people have
Right.
questions after those questions, I can slowly ask questions one by one.
Okay, sure, not a problem. Can we pause for a bit here? My somehow magically everything has upgraded very fast. I am sorry to cut short the discussion, but I'd like to get on with the demo. Is that fine with y'all? I'm really sorry, but I didn't expect it to go this fast. It normally does not happen. Must be my lucky day today. So,
It's
is it
fine.
okay
It's
if
fine.
I
We
go
can go
forward?
ahead with the demo. I think most of the
Yeah.
people will be waiting for demo.
Okay, so essentially, you're going to see what I have on my laptop, but that's fine. Um, so essentially, this is the YAML file that I'm going to deploy. I earlier on said, right, that I'm going to deploy applications running on the Spin framework. That is exactly what this sort of defines. So the Spin framework uh, is going to deploy the WASM time runtime, which is the runtime we need for the module to function, right? And the module that we're going to write is already in the form of a container image. We've packed it all together. This is the container image. This will all be available later on. Don't worry. I will provide the links to all of this. But essentially, we're just going to spin up this particular application, that is WebAssembly module, running on the WebAssembly runtime, that's wasm time, and this is supported by the Spin framework. And we're going to get this up and running on our K3s cluster, which comes packaged with Rancher Desktop. So I'm not going to save this file because it's already there. I'm just going to hit kubectl apply. Hopefully I've done everything that's required. Right. So what it does, it is creates the pods, creates the service, it creates all these things, and it's a very simple hello world application. So we're just going to see if okay. So essentially the deployment is not ready yet. I am not sure why. Let me just debug it. Kubectl get born. Okay. So apparently there is some uh, Okay, so there's some problem here. Now let me just see what is that. Okay, so the pods are not creating. Not sure why. Um, Let me refer back to my notes because I might be doing something wrong here. Given that I'm still functioning on some other time zone that I'm not doing well. So I've actually presented this demo at GDG Cochin as well. So I'm not sure if any one of y'all had the um uh I don't know if any one of y'all are there at that point, but essentially I presented this there. So I presented a longer version of this demo, and yeah, this is the steps and everything. This was on Docker desktop. Unfortunately, I think I forgot to apply the runtime class. Did I? Is that what I did not do well? Okay, so this is not really helping, but still. Um, so I'm just gonna do this once more. Not sure what I'm doing wrong here. But just a second. Typically, a pod comes up. Did I not enable it correctly? Is that what I did wrong? Uh,
If you have lens, can you connect to lens and see whether it's up or not?
no, I don't have Lens. That's the problem right now. I've not actually done it. So I've not actually installed it. So essentially, it should work. But there is some problem that I've not actually debugged. Um, but I'm gonna try figuring out. Just a second, kubectl. I'm just gonna delete everything and start fresh. Okay, so this should actually work. Hmm. So just a second. This should work. Not sure why it's not. Let me just do Rancher Desktop because I helped with the demo for this, so I might be just really jet lagged as the problem. But let me just do that properly. How to guides no. So WebAssembly. So essentially, this should be as simple as this: running WASM apps with Kubernetes, and yep, this should have been as simple as this. But clearly, I cannot do that well. Uh, I'm just gonna do something. I do not know what I did wrong though. And did we get this? Yeah, this worked now. So I think I copied only half of the file. That's on me. I'm really sorry. I helped write the documentation but couldn't clearly copy it right. So essentially, what I did was basically deploy a pod on the K3s cluster, and that pod contained a WebAssembly application running inside a WebAssembly runtime. So the demonstration was to actually show y'all that WebAssembly can obviously run on the browser because your browsers right now do support WebAssembly, but it can also run on things that are not the browser, things such as containers, which are very different from runtime environments such as the browsers. Similarly, you can also use the same thing, same concept that I just now applied, and actually use the Mobi runtime. So we if I can just go back, uh, clearly I did not, just a second. So if I can go back here, if you saw when I was going through this preferences menu, right? It obviously demands full screen. We have two container engines supported, which is Containerd and Dockerd, which is Mobi. So if you use this, you can directly run the WebAssembly workload on the K3s cluster in, and that is because Dockerd or Mobi actually has a shim that connects it better to those runtimes, unlike Containerd. Containerd basically allows you to deploy applications in a pod, but on Dockerd you can actually run the WebAssembly applications themselves. You do not have, like, it's a supported runtime, as opposed to Containerd, which is not a supported runtime yet. It's just able to package that into a pod, and we're able to run it just like we would run another application. So that is the live demo. And with that, I'm just gonna go to why should you care, because a lot of us are system administrators, and honestly, or even developers, like, why would you care about this? I just want to write an application, have it run on whatever systems it's supposed to run. Why should you care? um, Honestly speaking, I think this all boils down to write once, run anywhere. Because when we started off as engineers, or I'm pretty sure if anybody is doing a computer science degree even right now, the first thing that they're taught, even when they're taught about Java, is, oh, you know what, write once, run anywhere. That's the paradigm. But you can't do that. We're still working towards it actively, but it's really difficult, because across the ecosystem, across languages, there are so many languages to bring into the ecosystem that it's not really possible to say that we've truly achieved it. We're trying to achieve it with WebAssembly. We've tried in the past with a lot of the other things that I mentioned earlier on. So it's very difficult, and it's a very huge endeavor. So writing once and reusing that same code elsewhere, and having that code run everywhere, and having not to worry about, hey, will this run on X architecture and Y architecture if I actually target ABC architecture? You never know. Today that's the case, but it doesn't have to be if we actually support the ecosystem in developing the way it is today. For example, you right now saw that module, which typically was made for the browser, it is not, it I mean, if you go by the specification, it was initially conceptualized with the browser in mind, so it should not have run anywhere else, but today we've gotten it to work on all these places. So imagine the use cases that you can actually target with the without worrying about where you're running it. If you just have to write it in one language and be done with writing software, it improves your productivity, it improves the way you work. You don't have to write multiple versions of the same code. In the same way, essentially, if you are actually writing um, code in, say, one programming language, and you want to write it, you want to sort of use that same functionality in another programming language, a lot of the options today boil down to writing it separately twice. You don't have the option of reusing your code. You can't import code yet, because a lot of runtimes are not runtimes. A lot of languages are still onboarding support for WebAssembly. But with WebAssembly, the hope is that if you write a functionality in one language, you are able to compose it into a component, and that component, with all the interfaces and all the wrappings around it, can be seamlessly plugged into another program, without actually you having to take the burden of figuring out how to do the plugging and how to do the interfacing and all of that. That's what is the hope. Imagine the amount of time you're going to save, and imagine the amount of CPU cycles and compilation cycles it's going to save when this actually happens. It's happening for a really, it's been happening for quite a while right now. It's not widespread, but it is happening. And honestly speaking, it's being adopted by a lot of the big names. Like I was the co-chair for Cloud Native WebAssembly Day, and I know for a fact that Adobe has gone really big on WebAssembly and has actually gotten it to work in production for their Photoshop and Figma apps. That's actually in production. Even video game sites, right, they require quick refreshes, and they are also using WebAssembly. Like I'm not sure which video games, but there's a whole thing. Even Zoom, the communication software that we use, that also uses WebAssembly. So it's being adopted, but the thing is, it needs to develop as an ecosystem, and it's a lot of work. It's not it sounds simple when you're trying to implement it, but behind the scenes it's a lot of work. So you can help if you're interested, because I know there's a lot of interest in getting involved in open source, based on my conversations with a lot of people. So if you're interested in actually contributing, pick an area that you want to help with, because we have lots of work to do. We have obviously, like I said, different languages to onboard. We cannot say that we pick ABC languages and leave the rest of the alphabets right there and talk about writing once and run anywhere. That's not the goal. We want it to be portable across languages and architectures. So developing those things, libraries, runtimes, tool chains, actually do matter. And if you're an expert in those areas, we would love your help. And similarly, when we're talking about ecosystems, right, WebAssembly is an ecosystem of its own, but there's a lot of front end work that's involved in the browser side. Obviously it's not over. We're still very much developing. There are a lot of proposals in order to give it the functionality and to give it that seamlessness that we talked about. So none of the work that we're talking about is over. It's still very much work in progress. So whether you're talking about the browser intersection, or the cloud native intersection, or the serverless, or the AI, or whatever you saw a couple of slides back, all of those intersections are in need of help. And you can actually come in with your expertise to help there. And if you're more of a standards and compliance person, there is also help and required there, and your experience counts there too. But if you're like me, I started out with documentation, and I'm proudly going to say that everywhere I go, I started out helping with documentation in Kubernetes. And I did that because I had an inherent interest. I was trying to learn the technology, and I was not trying to become a maintainer. But I eventually did become a maintainer because of that, and also an ambassador and other stuff. But it also led me to learning more about WebAssembly, and now I'm a maintainer here. So there's areas for you to contribute everywhere that you look. So it's not necessarily just code. We also need efforts in the non-code side of the ecosystem as well. So if you're interested, please do reach out, and these are a few good places to start. These are all linkable, like they are hyperlinked. So once I share this presentation, you can definitely just click on the link and go to those places. And these are the resources that I've used while preparing the presentation. Again, all clickable, so you can actually you know go through them. And basically you can find me here. But I think I can leave these as links on the chat if you want to chat with me later. But I think we should go to the questions right now, because I've been talking for way too long, and I want to hear from others as well. So I'm going to stop sharing and we can get to the questions.
Yeah, we have two more questions. So before
Okay.
that, I'm pasting the feedback form for everyone and also the DevOps Malayalam website link in the chat. So please do, everyone, please do provide feedback. We need that to improve more. And coming back to the questions, um, yes, we have one question from Tom. It was in the beginning of the session, I guess it came. Can you explain WASI module more? So I think the whole presentation and explanation was around that. I hope, Tom, you already got an idea of what the WASI module is. If Divya, if you have something else, something more to add to it, to this question.
Okay. Yeah, so I understand that Tom was very frustrated by the flow of the presentation, but that context setting was really necessary because not everybody understands from scratch what we're trying to actually convey. Not everyone has the same experience level. The WASI module, so there's nothing like a WASI module, there is a WASM module, which is the fundamental unit of WebAssembly, like I showcased in the diagram before, and it will be shared in eventually. The WASM module essentially is the fundamental unit, and it has that structure, but you do not need to know more about the structure because it's what is the output of a compiler. It's not what you need to write. What you need to write is your program. You need to understand how to write programs first. You need to understand how to write software first, and then the compiler will actually do the job of compiling it to the module. So I can show you the structure if it's required, but essentially that's not something you should be actually concerned with unless you're writing a library or developing a library from scratch. And the module in itself contains only ints and floats, as we again saw in that black screenshot that I shared. You saw that a lot of it was ints and floats, and higher level types such as strings, such as structs, or anything meaningful really that you would write in a program was not there. That's because the WebAssembly module um, is basically defined in such a way that it's supposed to be closer to machine level than to a higher level programming language.
Yeah, thank you for that, Divya. So we have another question. It's from Vendila. I hope I pronounced the name correctly. The question is, how do organizations get benefited by integrating WASM? Was it helpful only for developers?
I mean, it's helpful for everybody, to be really honest. The number of cycles that you spend writing less code and writing more performant code, right? I mean, you do not want your as a sysadmin, one of my worst nightmares was this vulnerability being discovered uh, late in 2022 because of problem with the library that we had deployed. It was a Java library that had a problem, and essentially every JDK that we had on our systems had to be scanned. And that was an estate of around 80,000 plus applications. That as a system administrator, I have to go through every application that I deploy and check whether that application had that version of JDK or whether it had been updated. So I wouldn't want anyone to be actually there to do that, and I wouldn't want to do that myself, um, because it's a lot of effort. Imagine a team of 3 or 4 people actually having to undertake the effort, and it's normally falling on people like system administrators to do it. So it's not just for developers. If you write better code and if you're able to write a code that is easily pluggable, so like I said, with model the component model and with the whole component ecosystem, what we're trying to do is, if suppose you find that a particular component in the library has a flaw or has a vulnerability, you can easily switch out. There is going to be a functionality to easily switch out and switch in, directly updating it without you having to go through the overhead of actually taking on the updates. So that is in the works. It's obviously not done, But this is just to say that it has potential not just for developers, across the pipeline, across the you know deployment pipeline, right from the system administrators up to senior management. Everybody benefits from WebAssembly, because not only does it have that smaller footprint and the security and all of that, but it's less work in general once we actually get to working and building that ecosystem full-fledgedly around it. I hope it made sense. I know I went on a tangent there, but I hope it made sense. I think you're on mute.
Thank you. So I was on mute. So I was saying, Vanilla, if you are on the call, I hope that question answer was clear for you.
Yes, absolutely.
So thanks. Thanks for confirming. So next question is from me. Uh, so uh, so in Linux we have a concept of kernel space and user space. So I had a doubt, like when you
Yes.
say this pluggable module is running on a Linux system, what does it really run from? It's a kernel space or a user space?
So essentially, it runs in the user space, but there are there are projects like I don't let me just get the name for you. There's a kernel WASM project under WASM, or the same folks that were talking about WAS when I said WASIX. These guys have developed WASIX as well. There's a kernel WASM as well, which is a project under WASM, and this basically allows you to run WASM in the kernel, that avoids avoid that helps avoid most of those switching problems that I spoke about, right? But there is a project, but essentially it does run in the user space.
Okay, thank you for that. So
No,
now we have another question from Vinod Kumar. When it comes to running WASM module in the browser, could you please explain how we will ensure the security of the module running in the web browser?
so essentially, in the browser, it's typically loaded asynchronously using the fetch API, and then compiled and executed using the WebAssembly's API. So the execution is within the browser's sandboxed environment. So since again the and since when we are talking about sandboxed environments, the module is able to access only the things that it has been given access to. There's no way of injecting or manipulating the code like you could do in case of a typical application. So that is exactly how we ensure the security with respect to WebAssembly in a browser. Does that make sense, or do I need to go more in depth?
No, this was
Vinod,
good. Yeah, this was good. Thanks.
Okay.
thank you. So we don't have any questions anymore. So Adib, you
Okay.
had a few things
Yeah,
to
I had
be.
couple. Yeah, I
Yes,
had.
Yeah, yeah.
Can you hear me properly? Sorry,
yes.
Yes, we can.
sorry for my bad voice. So I'll start from one by one. So I understand. I mean, from your presentation, what I have understood is that we are using this particular thing. Let's say it's a framework or platform or runtime, just
Uh-huh.
because we get a better sandboxed environment, such that we'll have less memory footprint, less vulnerability, and safe and secure application. Right?
Hmm.
This is the basic thing, right? So,
Right.
first question. So, I'm overseeing products for millions of users in my organization and from
Okay.
a senior management level. Okay. So,
Okay.
as you know that in very larger organizations, we cannot rewrite applications if it is running stable on production, right? So,
Hmm.
it costs millions of dollars, right?
Right.
So, so is it possible that can I run my existing application
Hmm.
in a Dockerized version such that I have zero change in my application and only
Hmm.
I'm changing my configuration. Probably I change my Docker image, like, okay, instead of Alpha in Linux or something like that, I'll be running some kind of WASM Docker or something. And is it possible that without changing anything in the application, is it possible to run my application in the WASM Dockerized space? I mean, Dockerized container?
Yeah, so that's exactly what I was getting to, right? WASM applications, what you run, aren't changing from anything to anything. You're just taking your code and compiling it to a module. So essentially, if you're um, essentially you will not change your code. It will have to take on a different form. Like, for example, I'm going back to the virtual machine side of it. Okay, when we started off,
Mm.
when we talk about server side deployments, because I come from there. When we talk about server side deployments, what did we used to do? We used to write an application, we used to deploy it on middleware, and then we used to see it on the browser or mobile applications wherever,
Yes,
right?
yes, yes,
Now with the with containerization, what we're doing, we are adding an overhead of like packing it into a container,
yes. Because I don't
right?
want to mess up with my environment, right?
Right. So
That's
that
why
is,
I'm dockerizing.
yeah, so essentially you're packing it into a container. Now when you're talking about porting your existing code to WebAssembly, the WebAssembly runtime is essentially for WebAssembly runtimes to actually run code, they must be a WebAssembly module. Like, obviously, browsers are different, container runtimes are different because they also support other forms of code. But if you're talking about WebAssembly runtimes other than that, like a WASM time or a WASM Edge, the runtimes that are being developed specifically for WebAssembly, you will have to obviously compile it to a WebAssembly module. It will not run the other forms of code because it's designed to run a WebAssembly module. When you're talking about actually running the dockerized version or whatever, those are still possible. Like, for example, the hello world application that I talked about earlier, it's written in Rust and it is packaged in WebAssembly. So it's not like I had to rewrite it or I had to do anything with it. For a production use case, what I would suggest is we are still talking about WebAssembly modules being run alongside or run inside containers. So, porting existing applications, we haven't exactly come to that bit yet. Like, converting it into a WASM module will be still required. When you're talking about the runtimes
So,
that are there outside of Docker and outside of browsers, because those actually do support other forms as well. So Docker obviously supports containers. It doesn't only support WebAssembly modules. Java browsers support JavaScript and HTML and CSS. So it's not only WebAssembly modules. So it can run other stuff. But when you're talking about WASM time and WASM other stuff, when you're writing applications and then compiling it into WebAssembly modules, then only they can run in WASM time and WASM Edge, because it requires compilation into a module or a component for all of this to work together. Did that make sense?
does that means in my CI/CD pipeline,
Hmm.
you see, usually we have a Java build or Gradle build. Instead
Hmm.
of that Gradle build, do you mean that we'll have a WASM build command line in the CI/CD pipeline? Just for simplicity, I'm simplifying everything. That's what I'm asking, just for confirming.
So so that's a very good question. Essentially, what we're trying to do when we're talking about building WASM applications, right? Because right
Mm.
now with containers, we have a standard way of distributing those applications. With like, we have the OCI format, we have an OCI
Yes.
image to distribute. With WebAssembly, we've only made it an OCI artifact right now, just last year, I think. But we are also trying to develop a standard around WebAssembly itself. That is going to be somewhat like the OCI. So it's going to have a standard of distribution and build around itself. So right now, it's not going to be so WASM modules are currently OCI artifacts for the purpose and simplicity of distribution, but there is a standard that's going to be developed to build and distribute this on its own, because WASM modules are fundamentally very different from container images. So having it run like a container image and having Docker support us is great, but also I think there is a effort to develop standards of our own, since there are very more applications than a container. So to your question, currently you can distribute it and you can build it as like a containerized image, but it might change in the future. Does that make
So,
sense?
okay, so containerized image, I cannot build it. What about application, like building the
Adit,
application?
I'm sorry to interrupt you
Sorry.
guys in between. I know it's a very good discussion happening, but we have one more question in the chat. So Harish have a question. Can you suggest some courses to start on WASM, also for intermediate level?
So the only course that I know for WebAssembly, unfortunately, is the one offered by Linux Foundation. It's That's the only course that I know of. A lot of the learning that I do is personally by um, looking at talks and getting involved in the ecosystem. It's a lot of self study. We haven't put out good outreach content there yet. I'm afraid. So that's what we're trying to improve this year. Linux Foundation's course, if you want, I can actually link it here. Just a second, but it's very very basic stuff. So just let me get that for you. There's a lot of stuff in WebAssembly related stuff, courses in the Linux Foundation space. I can just give you that. There's WASM for legal professionals and all of that. So just a second. Like these are very basic courses. These are not really intermediate level, but this is all we have, unfortunately, and we're trying to improve. But yeah.
So do you
Yeah.
have a question, Arif, up to date? So